For problem 5, we have a sausage company that makes two different kinds of hot dogs, regular and all beef. Each pound of all beef hot dogs requires 0.75 pounds of beef and 0.2 pounds of spice, and each pound of regular hot dogs requires 0.18 pounds of beef, 0.3 pounds of pork, and 0.2 pounds of spice. Suppliers can deliver at most 1,020 pounds of beef, 600 pounds of pork, and at least 500 pounds of spices. This one is a little bit on the tricky side, folks, and I'll walk you through what's going on here. As always, though, we will start with our totals. So we have 1,020 pounds of beef available. That's what I'll start with there. We have 600 pounds of pork available. And we have 500 pounds of spices available. So we had, again, beef, pork, and spice. So again, that is going to be my step 1, everyone. I'm going to identify the totals, and I'm going to label them. Next, we're going to have some things that get put in this column to go with beef, pork, and spice. And we're going to have some things in this column that also go with beef, pork, and spice. So let's take a look. Let's read back through the problem. Each pound of all beef hot dogs requires 0.75 pounds of beef and 0.2 pounds of spices. So all beef requires, what did it say? 0.75 pounds of beef. And we'll assign beef the X value. Or beef hot dogs. I've got beef twice, so I'll delineate that. Beef hot dogs is what we're talking about here. We need 0.75 pounds of beef to make those, plus 0.2 pounds of spices. We don't need any pork. And so I could leave that pork blank, or if it helps you, we can put a 0 in there because we don't need any pork for our all beef sausages, obviously. And then the regular hot dogs, regular, requires 0.18 pounds of beef, so 0.18, requires 0.3 pounds of pork, and requires 0.2 pounds of spice. And so again, we will consider this to be our Y value, so we are assigning the Y value to the regular hot dogs. We add these up, and we need to remember to put our inequality symbols. So it is at most that much pounds of beef, so we have to stay under that amount of beef. It is at most that much pork, so we have to stay under that amount of pork. And it's at least 500 pounds of spice, so we can go above that amount in spice if we want to. Kind of interesting that this time we have 2 that are less than and 1 that is greater than. We'll see how that affects our graph. So I'm going to pull this off the screen, everyone. If you do need to write this down, go ahead and pause the video now before I move the iPad off screen. Again, I'm going to say new, don't save. I'll throw my equations in here, or inequalities rather, in here. Less than or equal to 1,020. And 0x, if that helps you, you can leave it out if it doesn't. 0.3y is less than or equal to 600. And lastly, we have 0.2x plus 0.2y can be greater than or equal to 500. And so again, I need to zoom out so I can even see what's going on with this set of functions here, everyone. It looks like our solution set this time is kind of interesting. So I'm going to very intentionally zoom in here on this. Because of that greater than, we no longer have this function running into the x and y axis. The only solution region exists right here. And so we don't need to put x equals 0 and y equals 0 because I'm not going to use the x-axis and the y-axis. I'm just going to be using these 3 points because those are the only corners that abut the shaded region. So as we've done before, everyone, I do need to still create lines for these, so I'm going to duplicate my inputs, and I'm going to put equal signs in each of them so that there is a line that is formed in GeoGebra. Okay, now we've got lines, so I can come to this tool right here, say intersect, and get to my 3 points. So I've got 3 points there, everyone. I could make 500 and 2,000, 880 and 2,000, or 1,000 and 1,500. Apologies for my pause in speaking there for a moment. I was just checking to make sure that I was doing this correctly. So with that, everyone, those are our corners, and we will go ahead and throw them down. I'll speak to them as I write them. So A, we would make 500 pounds of whatever X is, which in our case is all beef hot dogs. And we would make 2,000 pounds of regular hot dogs. That's point A. Point B is 880 pounds of all beef hot dogs and 2,000 pounds of regular hot dogs. And our third opportunity here is to make 1,000 pounds of all beef hot dogs and 1,500 pounds of regular hot dogs. And so I've written that on my iPad. I'll bring that up here for everyone. And what we are seeing here, everyone, is these are the 3 options that maximize the use of our resources that we have available: the pork, the beef, and the spices. And so at each of these points, we've created as much of something as we can using the resources that we have available. We are hoping to make as much money as possible. And again, from this problem, we can see that the profit is 60 cents on each pound of all beef hot dogs and 40 cents on each pound of regular hot dogs. So instead of this butcher just going through and saying, hey, you know what, I'm going to make, I don't know, 2,000 pounds of each. First of all, this person can't, because I will demonstrate if they tried to make 2,000 pounds of each. Let's look at our grid here. 2,000 here and 2,000 here is way over here. They ran out of materials to make 2,000 pounds of each a long time ago. It's impossible to do that. They could make any amount inside of here, but if I chose to make this much, for instance, I would be wasting materials because I would have stuff left over. So again, this process that we go through is using up all of the resources that we have as efficiently as possible and giving us the opportunity to figure out what to do so that we can make the most money possible without just saying, hey, let's make 1,000 pounds of this and 2,000 pounds of that. That's a terrible way to do business. I believe it happens all the time, though, and people are losing a ton of money because of it. So what I need to do is not part A yet. What I need to do is beef hot dogs. Sell for 60 cents each, so 0.60x. Regular hot dogs. Sell for 40 cents a pound, so 40y. And so our total profit function is going to look like 0.60x plus 0.40y. And then we can take our points and put them in there to figure out what the best thing to do is going to be to make as much money as possible. And so again, we're basically doing I don't know if it's the same amount of work in this case, but we are using up the resources that we have appropriately in these different options. And one of these is probably definitely going to be better than the others. So I just put the points there in. Same thing for the next. The next option is to make 880 pounds of the all beef and 2,000 pounds of the regular. And lastly, everyone, option C is to make 1,000 pounds of the all beef and 1,500 pounds of the regular. So as we've done in the past, we'll bring Wolfram over to evaluate these scenarios. And we end up with 0.60 times 500 plus 0.40 times 2,000. And we get a profit of $1,100. That seems like a lot of work for that much profit. We'll see if we can do better. So next we have 880 pounds of regular and still 2,000 pounds of, 880 pounds of all beef and still 2,000 pounds of regular. That's a little bit better with 1,328 as our maximum profit. And then finishing this out, everyone, the last option that we have is 1,000 pounds of all beef and 1,500 pounds of regular, which ends up being a profit of $1,200. That's a lot of sausage for not a lot of money. With that, everyone, we can say that for this business, the best option is to produce. And again, we found the best option to be right here. So the best option is to produce 880 pounds of all beef and 2,000 pounds of regular. And if you've been to the supermarket lately, you know that there's no way that you're going to pay 60 cents per pound for sausages. So this is grossly underpriced. I would be definitely recommending to this business that they increase the sale price of their sausages. So with that, everyone, that is it for number 5. My bad.